All right, so first thing we do is list. We can also identify the type of equation. This is synthesis because we've got two things making one thing, right? So let's just write that down. Then I'm going to list n is equal to 2, h is equal to 2, and over here, keep it in the same order, pretty easy here, n is equal to 1, h is equal to 3. All right, so what I meant about the common multiple is that there's no number that I can multiply h by that will make it 3, unless it was 1.5, but I'm not allowed to do that. But what I can do is look for something that both of these numbers divide into, or I can multiply them times each other. So 2 times 3 is 6. So what I want to do is get the hydrogen to 6 on both sides of the equation. So I'm going to change it over here first, because I always change compounds first. And that means I'm going to put a 2 in front of nitrogen. All right, so if I do that, I come over here. Nitrogen is now balanced on this side, and hydrogen is 2 and 6 over here. So I'm going to multiply hydrogen by 3. And now I have 2 and 6 on both sides of the equation, and it is balanced. Okay, we've got single replacement here. I don't think this one is too hard. I want to talk about this situation right here. So what does it mean when I have water and then below it I write HOH? So what we want to do is have both sides of the equation counted identical, and because I have OH over here as a polyatomic ion, I wanted to have it over here as a polyatomic ion also. And in order to do that, I took water, H2O, and rewrote it as HOH. So really, this is redundant. I'm just going to cross out water. I'm going to cross out the water and then just use the HOH. I just want you guys to know that that is a way to do that. Also, we would call this a double replacement reaction because we have two compounds reacting to form two compounds. And it's a special kind of double replacement. HCl is hydrochloric acid. Many acids start with hydrogen like that. Hydrochloric acid, sulfuric acid, nitric acid is HNO3. They all begin with hydrogen. Anytime you see a compound with OH as the second part, that's a base. So this is an acid-base neutralization reaction. Okay, the rest of this one is very straightforward. If you've worked it with me already, you know we're going to count. Hydrogen is 1, Cl is 1, Na is 1, should be an equal there, and OH is hydroxide, that's a polyatomic ion, and that is a 1. On this side now, we're just going to count using this version of water. That means I can count H as 1, OH as 1, Cl as 1, and Na as 1, and this equation is balanced already. We did not need to add any coefficients.